Subscribe and press this bell icon to never miss another lecture video. Hi, welcome to GATE ESE lecture. We are in lecture number 31. We are in continuous time system module, and here we are going to discuss about causal and non-causal system. Causal and non-causal systems. System. I'm not talking about signals. For signals, we know what is a causal signal and non-causal signals, but here we are going to study about causal and non-causal system. Extremely important subject, extremely important topic. I'm going to give you detailed analysis of this causal and non-causal systems, because how it will going to helpful. Now there will be a question, there will be direct question in which that you must be needing this causal non-causal systems, the point of the concept of causal non-causal system. If you don't know the causal and non-causal system concept, you cannot solve that question. Okay, so you must need to know what is a causal and non-causal system. Now listen to this carefully. Basic difference between causal system and non-causal system is, if the output of the system yt output of the system, I'm talking about causal systems. System is system to whom that I'm giving an input x of t, and in the answer I'm getting an output, I'm getting a response y of t. Now this system will be said to be as causal system if the output of the system at any time t only depends on present input, past input, or past output, then it will be regarded as causal system. Non-causal system is if the output of the time system at any time t depends on present input, past output as equal as that of causal, but along with that future input and future output, then वो non-causal system हो गया. सर कोई फ्यूचर इनपुट फ्यूचर आउटपुट के ऊपर कैसे डिपेंड करेगा? हाँ, वो क्रिश फिल्म में देखा ना, क्रिश फिल्म में जैसे वो उसका बाप बना था ना, वो कैन प्रेडिक्ट अ फ्यूचर. हाँ, वो जादू वाला केस वही बस बना सकते हैं नॉन कॉजल. दैट इज़ वाई दिस इज़ नॉट रियलाइजेबल एंड दिस इज़ फिजिकली रियलाइजेबल. ये खाली आपको कोई मिल गया और क्रिश फिल्म में दिखाई देगा, जहाँ पे आप फ्यूचर इनपुट को प्रेडिक्ट करके फ्यूचर आउटपुट प्रेडिक्ट कर सकते हो. यू अंडरस्टैंड दिस पॉइंट? So it's a very beautiful point, it's a very beautiful concept, whatever. So while you will solve a couple of questions, now you will get a clarity on this concept. Okay, only you need to remember is, if there is a system, no need to remember all of these things, only you need to remember is, if you have a system and the response of the system, the output of the system is depending on future input, future output, then that is a non-causal. So always try to, if there is a testing, like if there is a system which is in a test, just first find out for it is to be non-causal. पहले आप non-causal के लिए निकालो. Once you get the confirmation that this system is coming out to be non-causal, then things will be getting easier. Things will get easier. You understand? Okay. This is your second point. The first point is the definition, second point is the physically realizable, and this is physically not realizable because it is depending on past input and present input. Third point is very important point. Impulse response is 0 for t less than 0, and non-causal impulse response is not 0. Now what is the meaning of this? Now listen to this carefully. You have a system to whom that you are giving any excitation, and you are getting a response here. Now if your excitation is an impulse excitation, then the response will be regarded as impulse response. That means the response of an impulse input, that is why we are calling it as impulse response. So causal system mein this impulse response will be 0 for t less than 0. That means it will only defined for the positive value of the input, a positive value of the time instance. That is, it will only defined for causal system. Causal system हम लोग ने causal signal हम लोगों ने पढ़ा था ना. What is a causal signal? Causal signal only takes the value at the positive side, positive side, positive side. That means whatever the response of the system will be, the response of the system will not going to be defined for t less than 0. सर मेरे को एक क्वेश्चन है, हाँ को बोलो सर. हमेशा हम इम्पल्स रिस्पॉन्स को क्यों प्रायोरिटी देते हैं? Why we are giving so much emphasis to impulse response? To why not we are not analyzing for step response, for ramp response? But every time, even in control system while I was studying na sir, even if when we are getting the communication also, sir, impulse response is playing a vital role. हर जगह पे आप impulse response बोल के हम लोगों को बता रहे हो. Sir, why we are taking impulse response? Because whatever the graph that you are seeing, look here, whatever the graph you are seeing in this universe, every graph, every continuous time domain graph can be all of the can be nahi, all of this graph are made up of train of impulses. That means any graph, if you take any instant of time, like if you take any instant of time of this graph, that can be represented as an impulse function. So that is why impulse can be a part of any kind of graph. That is why always, if you know the value of impulse response, if you know if there is this a system, and if you know how this system is respond to an impulse input, that means you are getting a knowledge of impulse response for the system, then you can have the idea for any kind of graph that could be given to this input. Because अगर आपको impulse का response के बारे में idea है, तो हर कोई भी graph का आप कुछ भी mathematical calculation करके निकाल सकते हो. Because impulse are train of impulses मिलके ही एक graph होता है. Clear है? Now fourth point is very important. Fourth point, look here, fourth point. If there is a one input called x1t, if there is an input called x2t, x1t, who x1t का behavior less than t1 is equals to the x22 का behavior less than t1. That means x1t is equals to x2t for t less than t1. Listen to this carefully. For system to be causal, if your x1t and x2t both are following same property, both are responding the same way, till t is less than t1, like till t1 we are getting the same value, and there is subsequent output, then there is subsequent output less than t1. अगर ये 5 सेकेंड है ना, अगर ये 5 सेकेंड है, then their subsequent output will respond the same value t less than 5 seconds. Clear? So I can say if this is your condition, then y1t is equals to y2t for t less than t1. Clear? For all value, or you can say it this way, for all value of t less than t1. Clear this point? Because so this is the property for a causal. So systems to be causal, that means you can conclude that the system could be a causal. So please remember this 4 point. First point that I told you regarding the definition. Second point, it is physically realizable or not. Third point is how it is behaving to the impulse response. And fourth point is the graphical representation or graphical conclusion. Now let's solve a couple of examples. You will get a clarity.